Hi everybody, Teacher Nick here. So today we're going to be having a look at the Japanese method of multiplication. You might want to teach this to your kid. It may come in handy when they don't have a calculator to work with, you know. So just like any other method, as the numbers get bigger, the method also gets a bit more and more complicated. All right. So we want to start by multiplying, let's say 23. Oh, my handwriting there. Okay. So it's 23 times 31. Of course, you can use the method that you've learned in primary. It's all good. We'll make this a bit smaller and move it up. So that's what you want to do. 23 is 23 times 31. So this is the method. So you're gonna need a ruler. Well, you don't really need a ruler, but anyway. So I'm gonna just put it 51 degrees there. And then, so 23 starts with 2. So I'm gonna throw 2 lines. So the first number is the one that's gonna be having lines that are slanted like this. All right. The degrees don't matter. You can put it however you want. So I'm gonna go and say 1, 2, okay, and then it's 23. So I'm gonna skip and create a gap, and then from there I'm gonna move this up a little bit, or maybe make it smaller. Yeah, I think that works. And then I'm gonna leave a gap and put 3 lines. So this is how I write 23. So now 1, 2, 3. All right. So that is 23. 23. Okay. Now I need to write the 31. So I'm going to flip this over like that. So it's 31. So it's going to be 3, 1. Okay. So it's going to be, let me use a different color. So it's going to be 1, 2, 3. Now remember it's 31, so we're going to leave a gap and then have 1 there. All right. No longer need a ruler now. Okay, so the next thing that you're going to do is to count the intersections where the red line meets the blue line. So here you're going to have 1, 2, 3. So 3, 3. So this is 6. So you have 6 intersections there. 2, 3, 4, 5, 6. Okay, we got 6 there. And then you come here. If the number is this small, this will be your first digit, and the one that I'm calculating here across, this is going to be the last digit. So that's the first digit. This is the last digit. So the last digit should be 1, 2, 3. So now I know that my answer, the last digit, should be 3. But what's going to be in the middle? So that's the first digit and that's the last digit. All right. So the middle digit. So I have 1, 2. So I've got 2 there. And here I've got 1, 2, 3. So I've got 3 of these here. So it's 3, 6, 9 basically. Or if you want to count all of them in fine, so it's 3, 4, 5, 6, 7, 8, 9. So there you've got 9. All right. So these ones in the middle here will give you the middle value. And when you start writing the number, you're going to start writing the number from the right to the left. Okay, so these two, we're going to add them up. So when you add them, so 2 plus 9 will give you 11. Okay, now let's write the final answer. So this means our final answer here will be 3, will be the last number. So the middle number is given by these 2. So if you add these numbers and they give you a 2-digit number, you're only going to take the 1 which is on the right. So this one that's left, I'm going to add it there. So I'm only going to take just 1. there. I'm no longer going to look at this 11. I'm just going to take 1 there. So it means the next digit is 1. So this 1 that is left, I'm going to add it there. So 6 plus 1 is going to be 7. So that means that is going to be my answer, 713. So if we're to check that now, okay, my calculator is gone, so I'm going to use this one. So if I say 23 times 31, that's what you get, 713. Voila. Let's do another example with a much smaller number. All right. If I was doing this live, I would just say, give me a number, and then we do it together. But it's all good. Let's get another one. So I'm just gonna split this up. All right. So now let's say we're looking at 14 times 14 times what? 14 times 17. Yeah, but this one's gonna have a lot of lines. I always try to make these smaller. I'm not sure if I want to continue with 17. Fine, let's go for it. All right, so I'm gonna start with 14. So 14 is 1, and then I have, maybe let me make it a little bit longer since I have 7 there. Make it a bit longer. And then it's 1, 4. So I have 1, 2, 3, 4. All right. Then I flip it over. I write the 17 now. So the 17 will be 1, leave a gap, then it's 1, 2, use the same colors this time. It needs a different color. Let's go green. So 1, then 2, 2, 3, 4, 5, 6, 7. Okay, so that's what we have. So if we're to count now, let me move this up a little bit. So if we're to count now, we have, here we have 1. Here we have 1, 2, 3, 4. All right, and then here we have 1, 2, 3, 4, 5, 6, 7. So this is 7. So this is 7. This is 7. This is 7. So in total, this is 28. Okay, you can count if you want. If this is 7, then we have 1, 2, 3, 4. These, so this is 28. And then there we have 1, 2. We have 7. Okay. So what does this mean? We're gonna add these two together, the middle ones. So 7 plus 4. Okay, I'm also getting 11 here. Totally a coincidence. So if I were to write my final answer now, I will take only one digit from there, which is 8. So I know my last digit is 8. Then I'm going to add the 2 to the 11, so which now gives me 13. So this is going to be plus 2 from there, which is now 13. And then I'm going to take only 3 from here. So the another digit that's going to come there is 3. So the 1, I'm going to take it and add it on to that one there. So 1 plus 1 is now 2. Then it means my final answer is going to be 238. Okay, so if we can try to check that out, and go and go 14 times 17, that will give you 238. All right, But there are situations where you're going to get only one number here, only, and when you add these two, they give you one number. And when you add these two, they also give you one number. I'm going to do another example before we go to multiplying bigger numbers. So let me get another example here. I'm going to try and make this example as small as possible so we can achieve our objective. So right now, just want to separate this quickly. Okay. Let's say now we are multiplying 23 times 12. 23 times 12. I think this one will be the perfect one. So I'm going to start by writing the 23. But mind you, I can start with the 12. It really doesn't matter. So we're going to go and say 1, 2. And then we go and say 1, 2, 3. All right. And then after that, I'm going to write now the 12. The 12 is simply just 1, not the same color. Let's have this one. So I'm simply going to say 1. Then here is going to be 1, 2. All right. Now, let's go into our counting. I'm going to move this up a little bit. Right there. So right now, so here we have 1, 2. So basically we have got 2 there. And here we got 1, 2, 3, 4. So we got 4 intersections there. Here we have 1, 2, 3. So we got 3 here. Then here we got 1, 2, 3, 4, 5, 6. So we got 6 here. So this one becomes pretty simple. You add these two together, they give you 7. So it means 23 times 12 would actually give you 6, 7, 2. 276. So when I write the number, write it from right to left. All right. So if you have to take this up now, so this is 23 times 12, which is 276. All right. But when numbers get bigger, this thing also gets pretty complicated, if I may put it that way. So let's check that out. We're just going to do one example of this Japanese method using big numbers. Come on, there you go. So let's do that. So what numbers am I going to work with? Let's say we want to multiply some like 52 times 46. All right? We don't know what this is, but our diagram can actually help us with this. So I'm going to make two very clustered lines here. So I need to write the 52. So it's going to be 1, 1, 2, 3, 4, and 5. The lines don't have to be exactly the same size. As long as you're going to be able to do crossing over, it's all good. So it's 52. So 1, 2. And then this is multiplied by 46. So I need 1, not the same color. Let me take a red, any color that complement each other. 1, 2, 3, 4. All right, but it's 46. So I'm going to come here and say 1, 2, 3, 4, 5, 6. So the red is my 46. Okay, and then you know the drill. You know the drill. So now we count the intersections. Okay. So here I have 1, 2, 3, 4. So it's going to be 4, 8, 12. Sorry, 4, 8, 12, 16, 20. So here I have 20 intersections. You can count them one by one if you want, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, until you get to 20. I'm just not doing it. And then here you're going to have 1, 2, 3, 4. So you got 2 rows, so it means you've got 8 here. Oh my God. Let me use my hand. If I try to type to write with the mouse, it just looks horrible. Okay, so here we say we have 8. Not 8, 8. Right? And then here we got 1, 2, 3, 4, 5, 6. So 6 plus 6, it will be 12. Got 2 rows there, so it means you got 12. And then here we got 1, 2, 3, 4, 5, 6. And then how many rows do we have? 1, 2, 3, 4, 5. So system 5, so we got 30 intersections there. I'm going to write the 30 there, if you don't mind. Then let's work this out. I always want to start with this and put this together. So this gives me 38. 8 plus 30 is 38. So when I write my final answer now, remember, I'm only going to take the last digit everywhere. So I'm going to take the last digit here. So my last digit is 2, which means I'm going to take the 1 and I'm going to add it there. So plus 1. So now I have 39. Then this means the second digit I need to take will be 9. So that means there I have 9. And then the 3 that is left here, I'm going to take it and add it here. So it's going to be now 20 plus 3 plus 3. So basically I have 23. Yeah. All right. So you put the 23 as it is. So it means 52 times 46 will give you 2,392, and we can verify that by going 52 times 46. That will give you 2,392. All right, guys, thank you very much. I hope you enjoyed this Japanese method of multiplication, and look out for more videos, which I'll be doing in the next few days until I get tired of doing this. You know how it is. Otherwise, peace out.